All right, we're back, and I think I got the audio fixed. Let me know. All right. There we go. Sounds great. All right. OBS. Figuring it out. Yes, the CCP is hacking the stream, guys. Sweet. We'll get started in like 3 minutes or so. But if you guys want to ask any questions in the chat, go for it. Just answer whatever you got. Or if you just want to say hi. Yeah, I was thinking about just making a video. I'll probably also make a video, but I haven't even like opened this device up yet. So I figured let's do a live stream, right? Oh, will I be at DEF CON this year? Yes, I will be at DEF CON this year, and stay tuned, but definitely will be hanging out at the Embedded Systems Village. So yeah, stay tuned for that. Definitely excited. Got DEF CON booked. I haven't been able to go the last couple of years, but we'll be there this year. Oh gosh. Okay, so Mike Stewart, do you ever get the suspicion that these vulnerabilities are by design? This is really tricky. Like, there's some vulns that are really obviously like a backdoor, right? And then there are some vulns that pretty obviously look like a mistake, and then there's a whole bunch of gray in between those two. And it's really hard to infer intent when you're reverse engineering the binaries, right? Or like software. When you're going from something objective to trying to like reason about the subjective intentions of the people who made the product, right? That's tricky. That's tricky. Yeah. Oh, dude, not 2600. Wait, I assume you mean gosh, what's the name of the conference that the 2600 people do? Why am I blanking on that? Hope. I've been to Hope a couple of times, but just haven't been recently. So yeah. All right. When are you going to do a video on the T76? Well, I'm glad you asked, because we are going to try to use it on this device. I haven't had like a chance to like, well, I could probably do a video on the T76. For those of you that don't know, that's the Universal Programmer, the new XGECU device, and we're going to hopefully use it to do firmware extraction on this. But I'm going to show you that it might bug out on us and not work. And I have the T56 as a backup to the T76. So, but we could probably do a video on it whenever. But it's having some problems with Wine, especially when reading eMMC chips. So I still have to use the Windows software and RDP into my Windows laptop, which is like sitting up here on the desk if I want to do that. So yeah. All right, I'm gonna try to answer some more questions, and then we're gonna jump into this because this is cool. As we speak, I'm in a hospital room. I hope you're not hooked up to one of these. Actually, you'd probably be fine, but it'd be funny if you're hooked up to one of these patient monitors. What was the first IoT device you successfully hacked? A random router that I bought from Goodwill, which if you're not in America is a thrift store, right? That's what I suggest everybody do. If they're looking for a project, just go find like a place that sells used crap and then buy somebody's old Wi-Fi router. And then you have the additional challenge of assuming they didn't factory reset it. No one ever factory resets their Wi-Fi router. You can try to reverse engineer their SSID and password out of the device. So it's a fun forensics exercise. Yeah, the T76 is not going to get you the Universal Programmer. That's not going to get you a whole lot of upgrades from what I can see over the T56. I keep messing up these. Anyway, the new one is not going to get you a whole bunch over the old one. I don't really understand the value proposition yet, but I bought it, for the content, right? Have you ever tried to hack a Cisco device? Does Linksys count? Yeah. Have you reverse engineered your programmer? No. I submitted a patch to the Wine USB driver, if that counts. I don't think that counts. What serial terminal software do you like? I use PicoCom. They're all the same. That's my maybe unpopular opinion. Ubiquiti or Aruba? Dude, I don't know. I'm still trying to figure out what kind of gear I want. I did the video on the Open WRT stuff, and it was okay for a while. I'll be honest, I've switched back to my TP-Link routers for now. I want to reverse engineer those, but I was having some connectivity problems. But all right, that's we can do some more questions later. Right now, we're gonna jump over to the device because that's what y'all are here for, right? So over here on the desk, we have got the Contec 8000 patient monitor. And, oh gosh, I turned it on. Okay, so I was just going to talk about that. Good. So this device is not plugged in, and it has a battery inside of it, which we are hopefully going to remove before we... Okay, did I shut it down? No, come on. It's booting up. That's like the second time I've done it. I've flipped it over, and then I hit the power button on my desk, and I turn the thing on. Okay, come on, shut down. There we go. Okay. All right, so this is the Contec CMS8000, right? This is a patient monitor. If you haven't watched my video on this, we've kind of taken a look at this from the network perspective. So over here is an excellent blog post. I'll eventually link this in the description when I post this up. But this blog post, oh, I think I can post links in the chat. Oh yeah. So there we go. So Team 82, these guys are some of the best like IoT hackers in the world. They do the whole pwn to own circuit, right? They're finding O-days and devices like this all the time. And so they put a blog post about this because all of the drama that was generated over CISA, declaring that there's a Chinese backdoor in this device, right? So what I did in the previous video is I actually looked at a very specific part of this analysis, and that was this protocol. I'm going to scroll all the way down here in Wireshark, that was like sending patient data out. And in this blog and in the CISA post, they talk about how this it's sending patient data, but there's other data that's like binary data that's not obviously patient data. Like here you can see that this text is like some of the patient data because you can code it, because you can go and manually put in like the hospital room number and the patient's blood type and like other stuff like that into the device if you want to. I doubt hospitals like are really going and doing that on the device very often, but we can see this data is flying off to some IP address, and maybe if your network is like really misconfigured and weird at the hospital, it would actually try to go out to the external internet. Probably not, but in the video, again, you can go watch it later, of mine, we decoded some of the binary pieces of data here by kind of just guessing and checking and hooking myself up to the patient monitor. So what we're gonna do in this video is I actually want to do like more of the hardware analysis. I haven't opened this thing up yet, but I've cheated because I've read this blog post. So here we can see that they've opened it up and they've got this NAND flash chip. So this is a TSOP 48 chip here that our reader, our XGECU reader, is going to be able to read no problem. Okay, so I mentioned there's a battery, and this is another thing I cheated about here, and they're like, don't get electrocuted. So we're gonna disconnect the battery before we open it up and start messing around, because it's not like there's an external power brick. There's actually, 120 volts AC going into the enclosure, so I don't want to be touching a bunch of stuff inside of this device with that going on. So, okay, that's enough of background. Let's go and open up the device. So, first thing I'm going to do is I'm going to come in here because there's this nice little side compartment that has access to the battery, so I can disconnect that. So, there we go. And now let's look up here. So you can see we've got like 2 screws up here. And so we're gonna go ahead and take those out. Oh, come on. There we go. I'm guessing you can't hear it because I think I have the audio filtering, but my new camera, the autofocus on this camera is so annoying. It sounds like, I don't know, it sounds like something squeaking every time the focus changes, like from here to here. I'm sure there's somebody that knows something about cameras that can suggest a quieter lens. That would be awesome. Okay, so we got those. I got those batteries, or excuse me, those screws out. And then I believe we've got a couple screws down here that we need to disconnect. Like I said, I've not opened this yet, but I did cheat. I did look at that blog post just a little bit. So I think, if my theory is right, these are the other two that I need to disconnect in order to get this open. Looked like there's some like tabs on the top. I have to get into. Oh, come on, man. All right. Hey, there we go. Nice. All right. So let's see. There's probably a way I can disconnect all this stuff pretty easily. Nice. Okay. We are in good shape here. So potentially later on, we can also look for a UART interface here, but that is going to get kind of dicey because I assume I need to have all this stuff. You know what? Actually, maybe I don't need that stuff connected up. Oh, and this is just the speaker, which I definitely don't need that connected. So we could potentially look for some UART on this device. That would be kind of fun. That would be kind of fun. All right, let's actually do that first. So what we're gonna do is I'm gonna turn on my overlay here. Oh, of course that just doesn't work. All right, how do we get that working? Oh, hey, so we're gonna quick break over here. I want to say thank you to Brian B. Found your YouTube 3 weeks ago and loving it as a software dev. I wanted to say thanks and respect. Well, thank you for the super chat, Brian. Okay, I don't know why my hotkey is not working here. Okay, so in case you're wondering what the heck I'm trying to get working. Oh, see, it works over here. What's going on? My overlay is working just fine on this page. Go over here. There, the overlay is working. On the desk cam, nothing. Well, that makes perfect sense. Oh, you know what? I know what to do. There we go. We got it. We got it. All right, all right, all right. So, OBS issues. Sweet. Okay, so now I've got my my multimeter hooked up, and you guys should be able to see the overlay on the screen, which is nice. All right, so Yumi and CNC, thank you, dude, for the super chat. Thank you, thank you, thank you. All right, I'm gonna go through some of your questions. Dude, yeah, thanks for the shout out, guys. Tyler Durden, nice name. Is this a different device than the one he decoded the protocol and made that script? Yeah, this is the same exact device. Yep, same device. I didn't actually open the device up until today, guys. All right. So what we have here is pretty obviously the UART interface. All right, we're gonna zoom. Okay, right here, we got 4 pins. They're filled in with solder, which is, you know, like, thanks, guys. So we're gonna have to finagle our way around that. But pretty obviously, we've got, okay, so these screws are grounded. Let me find ground. Okay, first pin. All right, we're good. Okay, so top pin is ground. You know what? That's so obviously UART. We don't need to like read the signals. Let me get something that I can solder into there. And again, this is gonna be kind of annoying because of the fact that there's solder already in there, and I don't have like a solder sucker handy or anything like that. And I don't want to use hot air because I would have to shield off a bunch of these plastic components, which is really annoying. You know what? Actually, okay, what we're gonna do is instead of soldering to it, we're going to use our PC byte probes. All right, that's what we'll do. Here we go. 1, 2, and 3. All right, so if you're not familiar with these are PC byte probes, and we've got a little pogo pin up there that we can connect to stuff, and I don't have to solder because, again, it's going to be kind of annoying in this situation that we're in. So I'm going to get 3 of those set up because that's what I need for UART. And now I am going to take some measurements first, I guess. Might as well. So now I'm going to very carefully not touch anything else on the board because I'm plugging this battery on the device in. Just, you know, just a little scary here. And then I'm going to need to, oh man, I'm going to need to get under here to press the power button, aren't I? Okay. That's what we're going to do. We're going to press power. Oh, and we're going to change to voltage reading on our overlay. Bam, there we go. So we know the top thing is ground, and I'm just going to be touching this screw because I found out that was grounded, so that's easier to get at. Okay, so under here, we'll just use the battery. We don't even need to plug the power cord in. Okay, bam, device is powering up. Okay, nothing there. Wait, really? Huh. Am I sure that's grounded? Are we actually booting up? It is. Okay. So maybe that's not our UART interface. It's really weird. Okay, we're in voltage mode. We're getting nothing on these. Really, man? All right. Yeah, we're not getting any voltages off of there. Yeah, that's exactly where we would, I mean, that's obviously got to be the UART interface. Oh, wait. I think that says USB by it. Maybe that's not it. All right. Well, we may have to ditch the whole trying to find UART mission and just go back to our other goal. All right. I'm going to zoom in here. Yeah. I don't know if you can see that. Does that say? Yeah. I think that says USB. Oh, no. It's saying like this is USB. Wait a minute. Yeah, which adapter? Okay, this is not populated though. That's right next door to it. And that also has 4 pins. What do we got here? Ooh, 3.3. So maybe this is like a non-activated USB connector. And what we actually have here next to the device. Oops. Shaky hands. Another 3.3 volts. Trying to see if I can get any kind of oscillation. And there's 0. 8 volts? What the heck? Well, all right. We're going to try to reboot again. I'm holding power button, and I'm hoping on the other side of this device, we are seeing... Okay, cool. So there's like a red light on the main part of the PCB when it's on. So now it's off, and now we're gonna let it boot up again, and we're gonna try to probe these to see if we see like a big voltage fluctuation. That's not really looking like it's anything valuable. Nope. And again, I really would have expected this to have voltage on it. Unless there's like some unpopulated components down here, which totally could be the case. All right. Oh, wait. There's another interface over here. Okay, let me try this one now. Get this into view. Where are we? Down here. Okay. There's this guy. Nothing. Nothing. Nope. Nope. Oh man, sorry. I just put my face in front of that. Now you guys get to be all out of focus. That's awesome. Come on, autofocus. There you go. Okay, another interface right here that I just saw. Ooh, okay, there's 3.3 volts. This looks like it. See, you guys are getting literally my first view at this device, so. And 0, maybe ground. Ah. And this is 5 volts, which actually makes sense because I actually see like a label here that says 5 volts. So, okay, we're gonna do the same thing. We're gonna power off the device. Okay, it's off. Now we're back on, and now we're gonna read this voltage right here. Do we see any fluctuation? Okay, let me look at the other one. Come on, no, that's just happening because I'm not staying solid on it. Hard to say if this is actually a UART interface. Oh, wait. No, it definitely is a UART interface because I think it says it. All right. You're going to get to look at me because I'm going to put my head here so that you don't autofocus out of. It literally says UART 5 right here on the PCB. Okay. Let's actually use our logic analyzer and see if we see any cool signals. All right. So what we're going to do, come over here. That's just my overlay control, and we're going to go logic. And we're going to hook up our logic analyzer and see if we can see anything interesting on device boot up on those pins. All right. Now, let's go back to our camera so we can get this all hooked up. So we got a couple options here with my logic analyzer. Again, I got the new, like, crazy expensive one. You don't need one that's this nice, but it is kind of nice. This, I wonder if this is gonna be big enough. Can I, like, no, of course not. Oh, actually though, these have these really nice clips here that I can use. So we will use that. All right. So first thing we need to do is connect ground to something. And okay, device is powered off. Let's go back to continuity mode real fast and figure out over here what is connected to ground on this interface. Not that we couldn't get ground from somewhere else, but nope. Okay, it is that third pin. Great. So that third pin is ground. Okay, let's zoom in nice and close. There we go. All right, and then we got 2 of these pins that were at 3.3 volts. So I'm hoping that one of those is a transmit line for our UART interface. And so we're just going to read voltages on both of them, since I'm not really seeing much of a fluctuation on my multimeter, but maybe I just have the timing off or something like that, right? There we go. We're all connected now. Okay, let's come over here and connect up the USB for our logic analyzer. There we go. It has recognized it. That's great. Let's go here. We only need 2 channels here. That looks good. And I'm going to delete this old analyzer that I had. And let's just start listening. Now we're gonna yeah, that's okay. Okay, that's kind of what we saw. There's not much, it seems, that is emitting from the UART interface, assuming this is the UART interface. So yeah, that's all right. So we don't have UART interface. That's all good. UART 1 on the PCB. Yeah, 5 pins, but it's labeled UART 1. All right, guys, awesome. Top middle UART 1. Let me see. That says UART 5. You guys are saying there's one that's labeled UART. That's a 5 pin. All right, chat. I need to read this closer because some of you guys are saying maybe the UART2 one next to USB. Somebody else said they saw a UART 1. All right. We will look. We will look for what you guys are talking about. Oh, yeah. Because, okay, that was UART 5. We didn't get much. USB, this guy right here, that says UART 2, I think. Here we've got, I don't know. I don't know, guys. I'm not seeing maybe what some of you guys are seeing. What do you guys think? Middle top connector, very top of the board, middle connector. Oh, very top of the board, middle connector. Oh, yeah, well, that is connected up to, ooh, yeah, maybe you got a good point. That's connected up to this top board. So I just assume that that's UART to communicate actually with this top PCB. Sorry, you guys can't exactly see what I'm pointing to. So somebody said that, you know, okay, yeah, there's this UART1 that's plugged in that's connected up to this top board. Now you guys maybe have a point that, like, it definitely could be a UART interface. It's just that it's for communicating with, like, the microcontroller that's up here on this guy. That's probably what that's for. What I'm looking for is, like, the console interface for this chip, which, yeah, it's just probably... Now, what's interesting is that if this really is a USB interface, if we were able to, like, figure out the right pin out and connect up to it with the USB cord and provide voltage over that line, that might yield a result. That might yield a console or something like that. But what we're going to do right now is we're going to move on past that, and I will definitely take that as an action item for later to look for UART. But right now we're gonna do the chip off on this interface here. So we are going to go ahead and power. We're just going to disconnect the battery, and we're going to move on to our kind of primary objective here, which is to do chip off firmware extraction and yeah, get the software off of here. So to do that, we are going to disconnect a bunch of these interfaces to be able to get this board off, because I just want to have this board off and get it onto my desk so that I can yeah, do a really clean chip off. All right, I'm just gonna try not to damage these when we're taking them off the board. Come on. Yeah, there we go. Yeah, that's good. Good. Come on, man. There we go. 2 more. Man. There we go. There we go. One. Okay, we have one more connector over here. Let's get this off first. A little bit. There we go. Okay. Wow. Okay, so we got these little hoses here. I'm guessing those are, like, important to know where everything is. So what we're gonna do is I'm just gonna take a quick picture on my phone with that, because there we go, because that might be important. All right, take this off. go. All right, and there we have it. We've got the PCB that we actually care about. Yeah, we can take a closer look at this thing too, because like, I really do think, yeah, man, this being labeled as USB, I feel like there's a good potential that we could get some kind of an interface, some kind of a console interface, maybe like ADB or something, but who knows. All right, let's get this out of the way now. And now we're gonna do our chip off here. And it's actually nice now that I don't have to do this under my microscope because I can just do it right here. So what we're gonna do is we're gonna turn on my fume extractor. I'm gonna get some gloves on because I'm gonna use a little bit of flux to pull this off. I'm also gonna tape off some of the plastic components nearby because I want to be able to get the chip back on afterwards. So don't want to melt that connector. There we go. And I'm just gonna be extra careful and tape all this stuff off. There we go. All our plastic connectors, don't want those to get warped. All right, so here we go. We got our flash chip there. And we're just gonna throw a little bit of flux at it. There we are. Now we got hot air. Yeah, this chip seems like it's gonna be stubborn. I just get the feeling. It's definitely not low temp solder that we're dealing with here. Ooh, there we go. Okay, we got that side off. Now I'm gonna try to move the heat to the other side. Oh, come on. There we go. We got it. We got it. All right. You know what? Yeah, this was plastic too. I'm a moron but I think we're okay because those are just like little, connectors and they're all connected. But yeah, I definitely should have shielded that because I can smell the melting plastic. That always smells great. All right, but our mission, should we choose to accept it, is to clean this up and then do our firmware extraction. Okay, so we will actually switch over to microscope for a minute. Some light. Here we go. Let's get that in focus. All right, awesome. Okay. Here we go. Oh, yeah. We definitely have some solder we need to remove here. Let's do that first. All right. So I'm gonna grab my soldering iron. I'm getting some wick ready. I'm gonna cut a piece of it off. All right. So we're gonna use some solder braid here to get this out of here. Draw that solder away. Nice. All right, that looks good. I don't see any solder bridges between the pins. So we're gonna go ahead and get some isopropyl alcohol ready. Onto a Q-tip, and now we're just gonna clean our chip up. Also getting rid of any of that flux, mostly because I just don't want that gross stuff in my reader. As best we can. All right, here we go. Oh man, I like see a piece of solder. Ah, it's like right there on the other side. There, oh. There we go. All right, how are we looking? Yeah, we got some over here too. Like the reader can usually handle like a little bit of solder, like a little bit of it being uneven, but you know. Uh-oh. And then I went and just bridged the solder there. Great job. At least I think I did. I can see it the other way. No, we're good. We good. We can zoom in to check. There we go. That all looks acceptable. Not great, but acceptable. All right. I'm going to clean it just a little bit more. Nice. Just evaporate that away with our hot air. Awesome. Go back to our desk camera. Come on. Autofocus. There it goes. Cool. Don't need air extraction now. Okay, so like I was mentioning at the beginning of the stream, I have the new X-Geku T76. Now, does it actually do that much? That this device, the T56, I probably keep messing up the name. 76, 56. So the newer one is smaller, and it comes in a different with a different ISP port here at the back, which is really annoying because you won't be able to use this TSOP 56 and 48 adapter on this one. Now, with an exception, I'm guessing you can use it for anything but a TSOP 56 chip, because I think it only uses these extra pins if it's over a 48 pin chip. So that's my theory. I haven't tested that yet. And we're gonna try to use the new device, which kind of works in wine. It kind of doesn't work in wine. So we are going to situate this chip. Okay, we are going to align our chip on the bottom with pin 1 facing up in the adapter, which is the way that it wants it. So okay, I'm gonna do that as best I can. The microscope is actually the nicest thing to use for this. Let me see. This is probably not gonna get in focus. I'm gonna need to take it out of the adapter, aren't I? Oh, it's okay. That's the maximum distance I can get without taking this thing out of the adapter. So I'm just gonna do it this way. I know that's fuzzy for me too. All right. Yeah, fine. I will take it out of the adapter. There we go. focus it. Thing is really not wanting to press down. Man, flip it around. This is what happens when you have too much caffeine before you do a live stream. All right. I've learned my lesson. Maybe. Okay. It's almost like there's too much wiggle room, like left to right here. There. That's much more agreeable. It's getting all caught up. Okay, I think we're making contact there. Nice. Okay, now let me show you the absolutely terrible design on this new device. And so here is the locking mechanism. You have to, you know, put it up and then lock it down with the socket in it. The problem is that the stupid ISP port that needs to connect to the back side here gets in the way of this lever. So you literally have to like have it in the closed position and then situate this where it's like ready to go in, and then pull it up like a little bit and then slip it in and then let it down. You can't do all this with this stupid ISP connector on there. So yeah, that's a big fail in the design of this device, because that's super annoying. And this like doesn't like click in very well, this little ribbon cable. It's not satisfying. I cannot tell if that is like actually connected or not. But there we have it. It is finally in. And now the moment of truth. Okay, so we do need to like, I just realized I haven't like read the chip number yet. You know, something I should have done before I... Okay, we're back. We're back over here, guys. Let's go into our software. And we're just gonna eyeball this. I'm just gonna manually inspect this. SCN00. Oh, awesome. Okay, this is great. This chip is like probably not actually going to be supported by the reader. That's the best. SCN00. Okay, to Google we go. SCN00. SA1T1. Okay. Maybe, is this the chip? What the heck? Sure, that one. Yeah, that's not going to be very good for us. Nope. Okay, so maybe it's the other identifier on here. That's actually what we're looking for. Oh, no, it is this. Okay, so it's this thing. Programmer. No way. Okay. I wonder if this is not programmed into this device, which would be crazy. I just want, that's not at all what I'm looking for. I just want a data sheet, guys. Is that too much to ask? Oh yeah, the best website ever is All Data Sheet. High quality information we get from them. Yeah, it's not, they're not really gonna give me a data sheet, are they? Okay, but Unite, yeah, I bet the XGECU doesn't actually like support this thing. So what we need to do, see the thing we could do, well, if I can find a data sheet, even if it's not officially supported by the XGECU system, we could potentially, you know, we could potentially find another similar chip and then just disable the check ID option that we have. So let me just see if like this manufacturer, what's the manufacturer name? Unite LC. Okay. Nope. That's a big nope. All right, awesome. Well, this might be a fail of a live stream, guys. Just try every chip one by one till it works. All right. You know what? Like what we need to do is we just need to try to find like a random like win bond profile for a chip that is a TSOP48. And then we just need to give it a good old read and like totally disable the check ID. What if we did that, guys? Let's see what happens. Error. Oh gosh, this is what I was talking about. This is what I was talking about. This wine driver is not ready for the prime time. Oh, that's awesome. That's awesome. Okay. Well, try to open it back up. Come on. Oh, did it read anything? Come on, man. Read. Of course the check ID fails. Oh, wait. I want to know, like, does it check ID as anything? Check ID is blank. Oh, that's awesome. Oh, gosh. Oh, yeah. I can disable the multimedia overlay. Thanks, guys. Okay. See, what we need to find is we need to find a data sheet that just tells me, like, what the specifications of this stupid chip are. Again, so I can find a similar one. Yeah, it's this one. All right, I think I already found that website, though. Like, couldn't find what I was looking for. Oh, man. All right. Well, we are definitely going to... Is this... What's this? Oh, yeah. Well, that's definitely what I'm looking for. All right. Let me try like another one of these. Just try like another random like win bond chip. Like of course it's not gonna work. Okay, read that firmware. Of course the device ID does not work. All right, we're gonna try one more thing before I punt on this live stream, and we do the extraction another time when I have done some research. So now what we're gonna do is we're gonna switch to the old school reader that I have here. There we go. ports. Let me show you. Okay, yeah, just all we're doing is we're inserting into the old adapter. Okay. Yeah. Let's do the same thing. Let's make sure it's lined up under the microscope. Nope. Here we go. That looks good. Okay, back to the disk. Yeah, see, like this, there's like a little bit more clearance. It's still really bad, because it's still really bad. Like this is really close to here, but it does clear. Whereas it doesn't, there's not enough clearance on the other one. Now, getting it in is another problem. There we go. All right, and now I need my other USB cord to connect up here. And over here, we need to actually exit this software, and we need to go to another version of it that I have here. I think this is it. XG Pro. There it is. Oh, yes, it's too old. Okay. It literally won't let me use this one. Forgot, I gotta do this one. XG Pro. Here we go. Okay, programmer connected. Yay. Again, I highly doubt that the old one is going to have a profile for this, but let's just check. SCN. Here, let's check if the prefix for some reason is like not correct. No, of course. Okay, just give me some kind of win bond. Yeah, it's an AND flash. Win bond. Something that's TSOP. This is like a shot in the dark. Here we go. All right, this is an old thing. Tools. I just want to read the ID. Whoa. Okay, the ID read. So that is something. So we're gonna disable check ID. We're gonna do a read. We might have found a profile, everybody. All right. This is the random stuff you have to do with this reader, and this is why if we have open source software for this, right? Like if I could find a data sheet, that's also a contingency of this pipe dream of mine. But if the reader software is open source, then I could just mess with the parameters and be like, okay, you could program in new chips without relying on the manufacturer. Like when you find oddball manufactured chips like this, but. This is what you often have to do when you have a chip that's not in here. You have to find a chip that's similar. And I literally just guessed at a random WinBond chip. So we're going to have the moment of truth coming up here. All right, guys. This is it. Okay, verifying. No. There's no need to verify. Oh, fine. $81 gigabit. That's how much free space I have on my storage. If you guys want to, smash that like button, share with your friends so I can buy another SSD. Just kidding. All right. It's the moment of truth. Is there like real data in here? Holy crap! There's some like, there's potentially real data in here. Okay. Where's my notes? Where that? Yeah, whatever. All right, we're gonna like save. You know what? Where we're gonna put this is we're gonna put it into like /temp firmware.bin. Save it. Okay, let's move /temp firmware to here. Okay, this is the moment of truth. Oh, it's binwalk v3. All right, I have to like. Sorry for your eyes, but we have to do it this way. Come on. All right. There's a bunch of there's a lot of signatures. Wow, there's a lot of signatures. Okay, but I do see some file systems in here. And this is looking like we actually, yeah, there's some like real strings. Okay, so now we're gonna do, this is epic. Okay, binwalk-e on the firmware. So we're actually gonna perform extraction. This is great. This is great. Why did CramFS fail? Okay, well, let's just go see if it did actually extract anything. No, it didn't. Okay. I forget what is like the binwalk. Okay, binwalk CramFS extractor. I forget. Do. Like maybe I don't have it. Low audio. Where is the CramFS extractor? Just tell me what it's using or what you're using to extract it on CramFS. Okay, do we actually have that? We don't. Okay. Oh, come on. Well, Arch Linux binwalk. Show me about all those optional dependencies. All right. Okay, yeah, Arch uncram FS. It's in the AUR, really? Well, what's it called? Oh, CramFS tools. Ah, thank you, Pancake Sparkle. That's exactly the kind of name that I would expect to know about Arch Linux packages. I like it. All right, and it says it's installed, but it's clearly not. So we're gonna reinstall it. All right. Okay, uncram. Why is it not in my path? What the heck? Okay, CramFS tools. Like, where's the direct Arch AUR CramFS tools? Like, where is it telling me that it's gonna like put that stuff? Oh yeah, it's not gonna be able to tell me that. Where is it? Where does it install? Why are these URLs not working? There we go. Yeah, I mean I could run where it is. Only make CramFS. Back to searching. All right. Well, it was a good try. It was a good try. All right. Package uncramFS. Yeah. Like. Okay. This looks like it's a thing. Is that actually the one? Oh, is it in firmware mod kit? Firmware mod kit. Okay. firmware mod kit. I don't know. I should have this already. Oh gosh, Black Arch. And then an outdated one. What great choices we have. All right. Which one are we gonna YOLO here? Okay, we're gonna try Black Arch. Uncram. Nope. Really? Where is uncram fs? Firmware mod kit has it. Firmware mod kit. Okay, let me, I know we just alleged that to install this one, but yeah, that's really out of date. Oh, but it's the same thing. Bin. Use firmware mod kit on it. Cram. Okay. Extract into dir. Oh, well, will it use that though? Oh, what am I doing? Yeah, it's still failing. Okay, I know there's a way to have it print our extractors or something like that. L. Does it tell what cram fs extraction utility is 7Z? Really? Well, we have that installed, but I kind of doubt that. All right. So let's just go back to the output here. Also, there's way too much output. What the heck? I'm really only interested in the file systems. Although it's saying there's a checksum error, so maybe this is a false positive. Maybe it's a false positive. So even if we DD this out, are there any? Yeah, so these could just be total bogus false positives here. Let's look from the top. Total size, checksum error. Yeah, I mean, so it might not actually have that file system there. And also, oh wait, guys, wait up. I'm an idiot. Okay, so this is the wonderful software that we're dealing with here. Okay, please scroll. I have to scroll down slowly so this loads. Oh, come on. Spare area, none. There's spare area, so it's adding extra crap from the spare area of the flash, and that's why. So we gotta reread this. I assume. Let's hope that this is the reason why we got a bad read. All right, so we're going to redo our read. Here we go. Okay, forgot about that. All right. It's really interesting. It says it just uses straight the 7Z package. It uses 7Z for a lot of stuff. CPIO, GramFS. That's interesting. How are you sure what the actual flash size is? I don't know what the actual flash size is. I'm hoping that, yeah. So the problem, whoever made that comment, that's a very good point, right? If this random WinBon chip profile, I'm hoping that it's bigger than or the same size than our actual chip. And then it would just have zeros or Fs at the end of the file, and I wouldn't really care about it, right? We can actually do that. We can inspect the file. But first, I want to, have I tried using Debian? Wow. What a comment. How dare you? How dare you? All right. So we're going to, I don't need to verify. Who needs to verify? There we go. Okay. Oh yeah. Then we need to go back and hit save. And then we're going to save it here again. Firmware 2.bin. Saving the file. Okay. Move temp firmware to here. Okay, so you'll notice that it's like smaller. Firmware 2 is because it doesn't have the spare area in it. So let's see what happens here. Hey! Look at that. Look at that. We remove the spare area and we get a bunch of green success stuff. All right, let's go. Extractions. We got some cool file systems. All right, there we go, guys. That's fun. High fives all around. Exactly. Wow. Autofocus is like killing me today. This camera, that camera. I don't know what I'm doing here, guys. All right. So here we're just looking through some sweet file systems. Can you create a new profile for this chip? Again, it's like, this is not like open source software. There is Mini Pro, which is an open source implementation, but I don't think they actually do NAND chips yet. I don't think it supports the NAND chip profiles. So there is an open source project that tries to work with this hardware, but it's just not complete, which it's not their fault. It's like really hard to reverse engineer. Okay, cool. Bunch of shared object stuff. All right. I don't know. Let's just do some really like fun looking for things. Find grep shadow, any shadow files, any password files. Oh yeah. Okay, there's a bunch of them. Here we go. Okay, so the root is empty. Bin sh. Whoa, there's a PLG user with this amazing hash. Okay, let's try to let's see if we can crack the hash. No, okay. It's my favorite way to do password cracking is just to Google it and see if, or DuckDuckGo it or whatever, see if it shows up. But okay, that's interesting. There's some password hash. I'm sure you guys can here. You know what? Somebody wants to throw that in their GPU. There we go. I'll put it in chat. So we got that. So root is blank. Okay, so somebody in the chat remind me. I always forget this. If root is blank versus if there's an X, does that mean that there's no password, or does it mean that you just like can't log in as the user? I don't know. Because I know the star means like go look in the shadow file for the password. Yeah, I mean it's definitely using like it's not like MD5 where it's like descrypt. No, this is like descrypt, right? Yeah, because there's not even like a $ thing there. Do we need the shadow file to crack? You know, I mean, this is in the password file, right? You can put hashes in the password file itself. So, no, X, okay, so somebody says X means look into the shadow file. It's no password. Okay, so that means that like root literally has no password. So again, if we can find the UART interface on this device, it'll probably just drops us to a shell, right? Like let's be honest. So let's see if there are any other interesting binaries to look for. And the way we're gonna do that, we're gonna go back to the blog post and see if like there's any fun binaries that we should like especially consider. Okay. So they do some firmware. They look. Okay, so this is like the alleged backdoor, right? Is in this, and I don't think they actually say what binary this is in. but no problem, because we can look for this string, like NFS and then the IP address, right? Here we go. That's really funny. This like broke here. Okay. We'll fix that up. So let's actually look through the firmware for this. Is there like a weird white space in there? No, it just got rid of it. Oh, come on, man. Let's just try this string. No. What about the IP address? Look for the hard-coded IP. Really? Come on, man. Okay, so there is the possibility, although I don't think so. I don't think it's like a situation where, let's see, if there's just a bunch of like F's or zeros at the end of this file, then what I'm gonna assume is that, oh, well, yeah, I forgot. It's a much smarter way to do this, Matt. Tail, I don't know, like look at the last 100 lines. Of course it has to like stream it or whatever. I kind of doubt we're missing data. See, there's the end of our firmware read. It's all a bunch of F's. I don't think, yeah, I think we have all the firmware. Okay, so we were looking through the extraction there for that IP address. What if we look here? Maybe there's something that's still not extracting or decoding properly. Firmware 2, I don't know. It matches, okay. Let's just like go through here, because now I'm running strings and I can see contextually, like relative to other strings, where a string exists. Okay, so here's like obviously a bunch of variables of some kind, server IP. So this is like the alleged like Chinese server that it's calling out to, right? And here's the HL7 server, which is some like medical, information protocol. I don't know a whole lot about it. That's not the protocol we reversed. We reversed some custom protocol. Okay, so we're definitely seeing a bunch of these. That's interesting. Wait, okay. What the heck? So in our extraction, we're not seeing this, but we see it here. That's really fascinating. Okay. That's so interesting. Okay, so like this IP address, right? We don't see it in any of the extractions, but it's in the raw firmware. That's not right. So what I wonder, mount it. Mount what? Yeah, this is something I've noticed in the new version of Binwalk. Okay, so the old version of Binwalk had a really cool feature, like a DD feature. Oh, okay. You know what? I didn't use the M flag actually. Oh, let's redo this. Let's redo this with -E, -A, and M. So A is like all signatures, even the ones that are not like high confidence. So there's a lot of false positives you can get, but sometimes it's helpful to have that. Whoa. Okay, now we're on to something. It's trying to decode something. So there's some kind of extractor that I don't have. This. I get the feeling that's not the reason why I'm missing what I did, but oh, okay, so we extracted a lot more stuff. We extracted a bunch of zlib stuff. So let's now go. Now let's look for it. No, sorry. Like here. Still nothing. Okay, now we need this extractor, which, like, of course, binwalk-L. Okay, what extractor does, this is my little notes down here. SREC. Hmm. No, I really think we're missing something in the extraction. Yeah, I did ME this time. So I did the recursive thing. Yeah, we definitely... S record. I don't think that's why we're having the problem we're having. Try to diff. The two firmwares, the other firmware I definitely don't want to extract from that, guys. Yeah, it's it's, yeah, I know it's in the lit. Yeah, like those Motorola S records, right? Yeah. Yeah, I don't think that's why it's not actually like pulling the stuff out. Okay, so like if I just look at the signatures I see inside of here, let's do that again. It sees a bunch of ELF binaries, and it's like, it could definitely be one of those, but like why? Like it's not going to just extract that file. There used to be a way in the old binwalk where you could do like -dd and then say like all file types, and it would just just carve out all the file types. I don't know if that feature's been ported yet over here. Okay, don't care about that. Yeah. All right. You know what? We're going to... Wait, do I have it here? Okay, we're gonna try. Oh, dude. Okay, so in the chat, awesome job. Takia Gecko. I don't know if I'm pronouncing that right, but said the password is PLG, same as the user. Awesome. Way to go. Cracked the password. Okay, you know what? This is gonna be crazy, but we're going to go and go to binwalk. We're gonna go old school. We're gonna go back to the older version of it. And yeah, let's just copy that. Actually go back here. Woo. Okay. Oh yeah, it's just this is the package. Here we go. So we're gonna try out the old binwalk because it has a feature, again, like I said, where you could just merely just carve the files, and that might help me out here. We'll see. Maybe it doesn't. Unzip. Okay. Sudo. Oh wait, now it's like over top of it. Oh no. That was not smart. No module name. Oh gosh. Yeah. This is not, it's probably not a good idea to install this side by side. I still have this installed. Okay, here's what we're gonna do. We're gonna remove that binwalk. We're gonna try to get this installing, which is going to be terrible. I know. Is there an Arch package for the old one? What is this even? But it's a 2.0 release, so I might actually try this. That's funny. Okay, hang on. First, uninstall? I always forget how to do that. Okay. Sure, yay. Yeah, what is even virtual environment? I don't know. Who would use that? All right, let's try this thing. I don't even know what this Black Arch package is. Hello, do we have binwalk? No, it still wants like some Python imp package. What even is that? What? VM? You think I'm running in a VM? No, that's not happening, guys. All right. Well, I think we're gonna wrap up the live stream here. But we definitely got yeah. I mean, we could try this. I mean, you think this dependencies package is really gonna work in Arch? Like, there's no way. There's no way. It's just not gonna happen. Pac-Man? No, of course not. All right. But we definitely got some fun progress because we actually did extract these file systems, which is fun. And yeah. Oh gosh. Well, this doesn't even like have all those file systems. Anyway, we did. We were able to extract stuff, and we will explore that some more. And I'll probably make a full video of the firmware extraction for the YouTube channel. So yeah. Thank you guys for all joining the live stream. Yeah, I can just chill and answer some questions, but I'll probably get off in like 5 minutes. Can you look at the test points on the back of the board? Yes. Let's do that. Because I would love to find a UART interface on this. It's just gonna take some poking around. It's not exactly like a fun live stream, if you know what I mean. So yeah, I mean there's nothing really interesting here that is not like obviously accessible from the top side. That's the problem. So I mean, we tried a bunch of these like UART interfaces that weren't populated. This says USB, so I would love to plug USB into there. Yeah, it's hard to think it doesn't have a UART, but it could, you know. Well, the CPU's BGA, so yes, I could maybe get it from there, but that's gonna be really hard. Yeah, it says USB, but it looks like UART. I'm not even getting any voltages off it, and I forgot, like, again, I could try to find what the pinout is for that, and maybe like plug in a USB cord to it and see if that, like cut a USB cord and up and connect it up to here and see if that gets us anything cool. I mean, I was really thinking, yeah, UART 5. I was really thinking that would be the UART interface, but it wasn't. So, yeah. But you know, we'll be able to. I'll be able to do a lot more probing offline and maybe find a UART interface here. We'll see. It says UART up near the plastic connector. Yeah, all these say UART. This says UART 5. This says UART 1. You know, there's a bunch of them, but like they are UARTs to communicate to other microcontrollers. That's what they're for. I think you didn't see my super chat. Whoa, let me scroll up. I'm sorry if I did not see your super chat because I was a little focused. What the heck? Why can't I scroll up? I can't scroll up all the way. It's not letting me. Well, crap. Well, I'm sorry if I missed a super chat, but thank you very much if you did give one of those, because I cannot scroll up all the way in the chat. So, yeah. Well, I am going to call it here, everybody. Thank you for watching, and be sure to check out the YouTube channel, and I'm hopefully going to do a firmware extraction video if I can kind of wrap up this binwalk analysis stuff and yeah, kind of package it all up into a nice video and hopefully find UART. We'll see. We'll see. But have a good day, everybody. And yeah, a good weekend.